Let's half a blast learning. Welcome to Flash Revision Lab. I'm your tutor, and we'll master this topic in a flash. Today we'll be going through radioactivity, particularly focusing on half-life, contamination and irradiation. Because radioactive decay is random and spontaneous, it is impossible to know when a particular unstable nucleus will decay, but the rate at which the activity of a sample decreases can be known. Half-life helps us understand and predict the behavior of unstable isotopes over time. Half-life is defined as the time it takes for half the number of nuclei in a sample to decay, or for the count rate to fall to half its initial level. So what does this mean? Let's look at an example. Say we have a radioactive substance with an initial count rate of 1000 becquerels. After 5 hours, the count rate drops to 500 becquerels. This means that the half-life of this particular substance is 5 hours because it took that long for the count rate to decrease by half. In another example, imagine a radioactive isotope with a half-life of 10 days. If we start with a 100-gram sample, after 10 days, only 50 grams would remain undecayed. After another 10 days, 20 days in total, half of the remaining 50 grams would decay, leaving us with 25 grams. This process continues, with the amount of undecayed material decreasing by half in each successive half-life period. In other examples, you might be asked to determine the half-life of a radioactive isotope using a graph. When you're looking at a decay graph, you usually see the count rate or the amount of undecayed material on the vertical axis, while the horizontal axis represents time. First, you'll want to find the initial count rate or amount of undecayed material at the starting point, which is when time is 0. This will typically be the highest value on the vertical axis. Next, figure out half of that initial value. For instance, if the initial count rate is 200 becquerels, half of that would be 100. From this point, draw a horizontal line that reaches the curve, then a vertical line that goes from the curve to the time axis. The time value where this line intersects the horizontal axis represents the half-life of the radioactive isotope. In this example, the half-life would be 5 days. Next, let's talk about contamination and irradiation. Contamination happens when small amounts of radioactive atoms get onto a material. This can cause that material to become radioactive, leading to continuous exposure to radiation, which can cause more damage in the long run. One of the scariest things about contamination is that when a radioactive source gets into the human body, it can cause a lot of harm from the inside. Alpha sources provide the most contamination concerns out of the 3 types of radiations. This is because they are the most ionizing, so cause the most damage when in contact with the body. So how do we prevent contamination? You can use gloves and tongs when handling sources to prevent atoms getting onto your skin. Or wear airtight suits which keep you safe from breathing in radioactive particles. Irradiation, on the other hand, is the process of exposing a material to alpha, beta, or gamma radiation. When something is irradiated, it's exposed to radiation, but it doesn't become radioactive itself. The danger in irradiation comes from the radiation emitted outside the object. This radiation can mutate DNA in cells and even cause cancer. Gamma rays provide the most irradiation concerns as they can easily penetrate the skin and ionize the cells in the body, whereas alpha particles will not be able to enter the body as they get stopped by air and skin. To reduce the risk from irradiation, you could use shielding materials, like lead, which can absorb radiation and protect us from it. For example, people working with radioactive materials might wear lead-lined suits to reduce their exposure to radiation, or you could keep any sources in lead-lined boxes. And that's a wrap on these topics. Thanks for joining me at Flash Revision Lab. If you found this video helpful, don't forget to like, subscribe, and hit that notification bell for more rapid revision content. If you have questions or need some extra help, drop a comment below or reach out to us on our social media channels. Remember, with Flash Revision Lab, you're just a flash away from acing your exams. Until next time, happy revising.